Hello everyone, welcome to the next video on engineering mechanics. In the previous video, we have talked about equilibrium of coplanar concurrent force system, that is basically on spheres and strings. So today I'm going to talk about equilibrium of coplanar non-concurrent force system, that is which is basically deal with the support reactions in beams. As the term itself indicating, the support reactions in beam includes three major words. That is, one is the supports, and another one is the reactions, and another one is the beams. So if we deal about these particular three terms, that will be the equilibrium of coplanar non-concurrent force system. So let me, before defining what you mean by beam, support, and reaction, let me look at this particular diagram. All right. As we know that any structure which basically composed of different structural members, the structural members will always receive the loads from the particular structure and it transfers to the supports. As the support receives the load from a particular structure, it will also provide an equal and opposite forces. So it will create an equilibrium state. So if any particular member, while transferring the load to the support, if whatever the forces will generate, it is called as an action. The same way, the supports, after taking the load from a particular structural member, it is also going to develop an individual force. It will be equal and opposite to the applied load. That particular force is called a reaction. So there will be an action and there will be a reaction. The action from a particular structural member to the support, and from support to the force, from support to the particular member is called reaction. So when both the action and the reaction has been balanced, then we can expect the equilibrium state in a particular structural member. Here we are seeing that there are different kinds of the beams I am showing. First one, which is seeing that it is a simply supported beam. We'll discuss what you mean by simply supported beam. If you just take this particular example, here you see there is a one horizontal member which basically called as a beam, and it is rested on two different types of supports. One is a roller support and another one is a pin support or hinged support. So what we have to know? We have to know three things. One is that what you mean by a beam. A beam is a structural horizontal member. And second one is the support. These two are the different support over which this particular beam has been rested. To make this particular structural member in equilibrium, this particular support also has to provide some reaction. That reactions are called the reaction which developed in the particular support. So if I go to the first particular slide, that is to define what I mean by a beam and support and reaction. Now we understood what you mean by a beam. A beam is a structural element that is capable of withstanding the load primarily by resisting against the bending. Whenever we say about the beam means a structural element which has a capability to withstand initially the load which is coming from the higher structure, that is from the superstructure, against the bending. Without bending, it is going to resist. So if I define a beam is a structural element which has a capability to withstand the load. And it's also called a horizontal member, or a beam is also called as the length, or a length will, or the longitudinal dimension having higher dimension compared to its cross-sectional dimension. Second one is the support. Support means it is in a structure is a member which helps the other members to resist the load. A support means we saw that it is particularly taking the load from a particular beam. It is supporting the another member to resist the load. So support is a structure in a member which helps the other member, that is the beam, to resist the loads. Next one, and the supports will always develop an action. This action, how the action will develop? When a beam is rested over a support, whatever the load which is coming from the beam, through the support, it will create an action. The same way, for the particular action, that is from the load, whatever the force will develop, for the same force, there is an equal and opposite force will develop at the support. That particular thing is called reaction. So reaction is a response to an action that is acting on the beam in the form of vertical force. Example, if I written here, if this is an horizontal member, that is if I am considered that as a beam, and here due to the load in the support there is a creation of some action. For the same action, this particular support has to provide some opposite force. If it is equal to this particular action, then the structure will be under balanced condition. So this is particularly a beam, and there is a creation of support and there is a creation of action and reaction in a particular member. Now if you look at here, I am going to discuss about what are the types of beams, what are the types of supports, and what are the different types of loads. If I know about the different types of beams, supports, and as well as about the different types of loads, then I can easily analyze the beam. Right? So what are the different types of beams? First one is simply supported beam. What is simply supported beam? The two ends of the horizontal member, that is beam, has been rested on the supports. Right? Next one is continuous beam. What is continuous beam? If more than two supports which is exist in a beam, that is called continuous beam. That is the length or the span of the beam has been higher to come for providing two supports. So there will be more than two number of supports will be provided for continuous beam. What do you mean by a cantilever beam? Here you see, if you look at the diagram, in cantilever beam, only one end has been fixed, or one end has taken a rest, or it is rested over the one particular support, and another end is free. If one end is free and one end is fixed, that particular beam is called as cantilever beam. End supported cantilever beam, or it's also called as propelled cantilever, which means that the other free end has been rested over any support. Either it might be roller support, or either it might be a pinion support or hinge support. That particular type of a beam is called as propelled cantilever. In propelled cantilever, one end has been fixed and other end, the free end, has been rested over a small roller support or an hinged support. And the next one is a fixed support or fixed beam. What is fixed beam? The entire beam has been fixed on both the ends. Whatever the load which is coming above the beam has been taken by the beam through the help of the two ends has been fixed. The two ends has been fixed, and the combination of both simple support as well as from the other roller support is called as combination of the beam. The different types of beams we basically will use in a regular case, that is simple support, cantilevers, cantilever beam, simply supported beam, or continuous beam. Sometimes they will go for end supported cantilever beams. The most, wherever the higher amount of rotation and the higher amount of load is there, in that particular cases basically will go for fixed beam. Okay, next one. That is the explanation I've given here. The simple supported beam is the one simplest structural element, that is both the ends rest on a support. Both the ends has been rest on a support with, but it is free to rotate. Just it is rested over the support, so we can easily rotate that. When we come to the fixed beam, in fixed beam it is supported at both the ends and fixed to resist the rotation. Here you see, in the fixed beam, what has happened? Both the ends has been fixed at the both the corners, so there won't be any rotation. It is purely, it can easily resist any type of rotation which is coming over the beam. But if we look at the simple supported beam, it is only developing a reactional force against a vertical force. Only one type of reactions we can manage or resist. But if any type of rotational force which is acted on the simply supported beam, it is difficult to resist. But if any type of rotation which is applied on a fixed beam, we can easily resist that. Next, cantilever beam. As I mentioned, cantilever beam is one end is fixed and another end is said to be free. It's called as cantilever beam. Continuous beam. Continuous beam is a beam where more than two supports has been distributed along its length. It's called as continuous beam. We talked about the different types of beams and what you mean by a beam. Now the second part is types of loading. Basically, there are three different types of load has been used. One is the concentrated load. It's also called as point load, uniformly distributed load, and uniformly varying load. Let me discuss one by one. What do you mean by concentrated or point load? If you look at the figure, here you see the beam has been rested over two supports at A and B. There are two forces, or there are two loads, W1 and W2, which are acting on the particular beam for a span of L. If these particular two supports, if I consider as simply supported, there is a reaction from both the supports, which is acting vertically upwards because the action is coming from vertically downwards. So the vertical reaction as RA and vertical reaction as RB at the support. So here the load, whatever the load which is acting on the beam, it is acting exactly at a single point. Even though the W1, the intensity of the load has been assumed it is 50 kilonewton. All the 50 kilonewton load which is acting at a single point. Here also W2, if you assume 10 kilonewton, the entire 10 kilonewton load which will be acted at a single point. That particular thing is called concentrated or point load. The entire load, the intensity of the entire load has been acted over a single point. So that's why it is called as a concentrated or point load. Even though if we discuss the different types of load while solving the problems, basically we have to consider, or we have to convert all the different types of loads into concentrated load only to solve the problem, right? A load acting at a point on a beam is known as a concentrated or point load. That is, all the loads will be acted at a single point. Next one, that is uniformly distributed load. What do you mean by uniformly distributed load? As the term itself indicating that throughout the distribution of the load, it has the intensity of uniformity. That is, here you see in the figure, we show that here there is a W which has been throughout the length, W per unit length. The same simply supported beam I have considered here, but rather than a point load, I have considered the intensity of loading, that is uniformly distributed load. What do you mean by uniformly distributed load? A load which is spread over the beam in such a manner that each unit length is loaded to the same extent. Each unit, example, if I assume L equal to 5 meter, all the 5 meter length has been equally having the equal intensity. Example, if I take W as 10 kilonewton per meter, which means that if I cut the section at 1 meter, we can expect an intensity of 10 kilonewton. For another 1 meter, same 10 kilonewton, 10 kilonewton, 10 kilonewton, which means that the entire beam has been equally spreaded with the same amount of load. As I mentioned in the previous slide, while solving the problem, we have to consider even the different types of loads into a point load or a concentrated load. Example, if I taken this particular uniformly distributed load, how to convert this uniformly distributed load into point load? That is, which is equal to W. What is W? W is the intensity they have given here. So W into what is the total span of the beam. If you multiply the intensity into the length, will get into a point load, that is W. W, capital W, which indicates the point load or concentrated load. The small w indicates the intensity of loading. The load per unit length, if it is multiplied with the length, what is the span? So then we can easily get what is the magnitude of the load. So to convert the UDL, that is uniformly distributed load, into point load, we have to go for multiplying the entire intensity with respect to length. Now the next question is where this particular point is acting. After converted the entire distributed load into one single point, we know that we have to represent this particular concentrated load or the UDL load into one load, right? So to locate that, particularly the unit load which has been located at a distance L by 2. So if I taken this particular thing is where the entire concentrated load or point load is active. After converting this entire distributed load into a single point load, the single point load will be acting at a point. Where it will be acting at a point? The point is this particular point. What is this point? This point will be at a span of L by 2. L by 2 is the span where the entire UDL will be acting. So to convert the UDL into point load, we have to go for multiplying the intensity, that is W, into its span, and that particular load will be acting exactly at the middle of the particular span. Right? That is called UDL. Next, if I'm talking about the next load, that is uniformly varying load. Uniformly varying load which is spread over the beam in such a manner that its extent varies uniformly on each unit is known as uniformly varying load, which means that in uniformly distributed load, the load has been spread over the entire beam uniformly same. It should be same throughout the length of the beam. That is, here you see some purple color line. If that particular length has been present, then which indicates it is a UDL, but uniformly distributed load. But here, uniformly varying load, what is happening? For every unit length, the load has been varying in a gradually increasing manner. Uniformly varies throughout each unit length of the beam is called as uniformly varying load. Here you see the intensity at the starting point, which has been around W1 per unit length. The intensity at this particular point, that is B, which is W2 unit per length. Example, if I assume W1 equal to 5 kilonewton, then W2 will be gradually increasing and it will be 50 kilonewton per meter. Assume it is 50 kilonewton per meter. So from a span from 0 to L, the length or the load has been increased from 5 kilonewton to 50 kilonewton per meter. So the variation of the length for every unit length will be gradually changing. So as I mentioned, to calculate the reaction in a beam, we have to convert whatever the load which is acting on a beam into a point load. So to convert this uniformly varying load into point load, that is capital W, which is equal to W2. What is W2? W2 is the maximum intensity which present in a uniformly varying load minus W1. What is W1? W1 is the minimum intensity. So W2 minus W1, which will be multiplied with the span, that is L, divided by 2. In that particular uniformly distributed load, to convert into point load, we have taken intensity into L. So W into L. So here W2 minus W1 into L, and it should be divided by 2. So if you done that, now we will get a point load, that is concentrated load. Where this concentrated load is acting, that is the next question. So we know that whenever we convert any type of load, either uniformly distributed load or uniformly varying load, into point load, the point load is a load, it will be acted at a single point. So where this particular point is acting, in UDL it is acting exactly at the middle, so L by 2. But here it will be acting at a distance of L by 3 from the base of the uniformly varying load. So that is how to determine it is a base. So to determine it's a base, where you will get the maximum intensity of loading, that particular thing which indicates the base of the particular beam, right? The minimum intensity which indicates the apex point. So this is the apex point and this is the base point. In base point, remember, always the intensity will be maximum compared to the apex point. From the apex point, this particular point load will be acting at a distance of 2 by 3 of L. But from the base, it will be acting at a distance of L by 3 from the base. So 2 by 3 from the apex and L by 3 from the base. So whenever we convert uniformly varying load into a point load, to convert the intensity into point load, we have to multiply the maximum load, that is W2 minus W1 into the span L, that is W2 minus W1 into L divided by 2. And it will be acting, the point load will be acting at a distance L by 3 from the base point or 2L by 3 from this apex point. So this is the one of the important load we have to consider. So same way, if this particular point, that is the UD, uniformly varying load, if it is starts with 0 at one end and W at the another end, then how to convert? So they anyway they will provide the intensity, that is W. So W into L by 2 is the intensity of the particular uniformly varying load. This uniformly varying load is also called as a triangular load. When a uniformly varying load, if it is started with 0 intensity to some intensity, that is W, then particular type of load is called as a triangular load, and it will be converted to point load by using an intensity W into the span L, WL by 2, and it will be also acting at same point, that is when you convert it, it will be acting at L by 3 from the base and 2 by 3 from the apex point. So now we talked about the different types of load. That is, first one is concentrated load or point load, second one is uniformly distributed load, and the third one is uniformly varying load. Next one, that is the last one, different types of supports. As we know that whenever a load which is coming to the beam, then it has to transport to the support. When it transport to the support, it will create an action. So whatever the support is there, the support is going to create a reaction. When it creates a reaction, then the particular force will be under balanced. So it will create an equilibrium. So now we'll be talking about what are the different types of supports. The supports are roller supports, pinion supports, and fixed support. In generally or commonly used supports are roller support, pinion support, and fixed support. Pinion supports is also called as hinged support. So we'll discuss what we mean by a roller support. Here you see the best example for the roller support has been given here. The entire load which is coming from this particular steel beam has been transported to this particular rollers. This is the roller support. The support has been taken, whatever the load which is coming from this particular beam. This particular roller support we can easily rotate. Correct? We can take this beam and we can easily rotate. But this particular roller support is providing a reaction against the load which is coming vertically downwards. So whenever we talked about the roller support, always the roller support will create a resistance against the vertical force. Here you see, when the force which is coming from the beam vertically downwards, this particular reaction will create vertically upwards, right? So these are the different types of roller supports we can see here. Here you see the particular the roller support has been connected to a member. This is a member, right? So it is creating some forces over the roller support. This roller support is going to develop a reaction over this. So another type of roller support, a bracket example we have given. How the reaction will develop? It will always develop against perpendicular or normal to the distribution load surface or the contact surface. Against the contact surface, always there will be a normal reaction. That is, we can also represent as R. The reaction R will develop in the support. The small example I have shown here, a small roller support has been rested over a beam. How the reaction will develop? The reaction will develop exactly perpendicular to this contact surface. How the reaction is developing from the particular beam, it is transferring the load which is coming over this entire structure into vertically downwards. So this particular support will also develop a reaction against that particular support. So whenever we dealing with the roller support, make sure that always remember one particular vertical reaction will always develop in roller support. If I talk about a roller support, which means that there is a one vertical reaction will develop in the roller support. Next one, pin nut support. Here you see the example for pin nut support has been shown here. Pin nut support is also called as hinged support. This hinged support or pin nut support will basically develop a reactions against both vertical direction as well as a horizontal direction. That is, both the vertical reaction will develop and also horizontal reaction develops, which means that the hinged support or a pin nut support will always develop a resistance against both the transitional moment along the vertical direction as well as along the horizontal direction. So whenever we talked about a pinned support, make sure that we remember in pinned support or hinged support, there will be a development of two particular reaction against the transition, that is along the horizontal direction as well as along the vertical direction. So next one is basic commonly used one are fixed support. Fixed supports are well known for the resistance against the moment. In roller support, we talked that the roller support best usable for to develop a reaction or to resist the vertical force. When we talk about a pinned support or hinged support, it will develop a resistance against both horizontal direction as well as a vertical direction. What about if the particular beam has been under the action of rotation in that particular time? If the particular beam is subjected to rotational moment, then we can basically go for fixed support. How the fixed support helps? You see here, if any force which is applied on the particular beam, if that particular beam, if it is creating, the load has been applied vertically, the load has been applied horizontally, and assume there is a moment, there is also some rotation in the beam, there is a rotational force is there, how this is going to resist? Example, you see, we know that the fixed support is the one where the support has been fixed, right? So here you see, against this vertical force, there is a development of a vertical reaction against the upward, and also due to the horizontal force, there will be a development of a resistance force against horizontally, and also along a movement, there is a development of the anti-clockwise movement. There is a one more development of a resistance movement in the particular support. So whenever we talked about a fixed movement, always we should remember that there is a presence of both vertical reaction, horizontal reaction, along with there is a resistance against the movement. So in roller support, only one vertical reaction will develop. In fixed, in hinged support or pinned support, there will be two reactions. One is horizontal reaction and another one is vertical reaction. But when it comes to fixed support, there will be a presence of both horizontal reaction, vertical reaction, and also a resistance against the moment. If you look at this particular figure, here you see it has been fixed to the wall, right? It is going to resist the load which is coming along the horizontal direction also, and also it is going to resist along the vertical direction, and also, and if any moment which is created at this point, it is also resisted at the particular point. So it will be well suitable where there is a huge amount of load along with the moment on the beam. So next one, that is how to solve the problems on by using if the problems, if they are given in equilibrium of non-concurrent force system, that is on the beams problem. First step, we have to draw the free body diagram. Here you see the important thing is, while discussing about equilibrium, we have to either it's a concurrent force or non-concurrent force, we have to go for free body diagram. Draw the free body diagram is the diagrammatic representation of all the forces and moments which are acting in a structure. So that we have to write. Second one, convert all the types of load into point load. This is what I am talking about. We have to convert, even though if it is a uniformly distributed load or even if it is uniformly varying load, we have to convert all the load into a point load. And the third one is, as we know, it is a non-concurrent force system. So we have to go for applying the conditions of equilibrium. So if it is a concurrent force system, we can directly go for summation of f of x equal to 0 and f of y equal to 0. We can only dealing with the forces along the horizontal and vertical unknowns. But when it comes to non-concurrent coplanar system, so we have to go for the equilibrium condition, that is including the moment. So by using the summation of f of x equal to 0, f of y equal to 0, and summation of moment equal to 0, we can easily solve how many unknowns which are present in a particular beam. So the three things we have to remember while solving the problems on beams. One is first to draw the free body diagram. Next one is to convert all the different types of loads into a point load, and the third one is apply the conditions of equilibrium. So it is because of a non-concurrent coplanar force system, so we have to go for all the three equilibrium equations, that is summation of f of x equal to 0, f of y equal to 0, and moment equal to 0. So we'll talk about the problems in next class. Thank you.